Hello everyone, welcome to this video. Today I'm very excited to introduce my website and solution to the problem that is EduVault 3.0, which is my final year project at Ideas University, Institute of Information Technology. तो हम बात करेंगे प्रॉब्लम स्टेटमेंट की। हमारे पास प्रॉब्लम कहाँ पे आता है? प्रॉब्लम ये है कि एक स्टूडेंट है जो डिग्री को अटेस्ट करवाता है, फिर वो एचएससी में जाता है और एचएससी में जाके वो अटेस्टेशन और वेरिफिकेशन करता है, लेकिन वो एक प्रोसेस से गुजरता है जिसको हम नाम देते हैं ट्रेडिशनल सिस्टम। और आफ्टर दैट उसको डॉक्यूमेंट्स मिल जाते हैं कुछ इस तरीके से जो कि अटेस्टेड होते हैं, और एचएससी उसे वेरीफाई करता है कि हाँ हमारी ही यूनिवर्सिटी ने ये डिग्री इशू की है जो कि अथेंटिक है, और सेंडर को अथेंटिक करता है। तो ये हमारे पास प्रोसेस है जो कि एचएससी प्रोवाइड करता है। बट ये होता है कि प्रॉब्लम क्या है कि कॉस्ट, टाइम एंड जो तीसरी चीज़ें कि मतलब हमारे पास यहाँ पे नेपोटिज्म बेस पे प्रॉब्लम्स क्रिएट हो सकते हैं। नेपोटिज्म बेस पे कि मतलब फेक डिग्रियाँ भी अटेस्ट हो सकती है, फेक डिग्रीज भी अटेस्ट हो सकती है, गेट अटेस्टेड। और फेक डिग्रियों के साथ साथ ये भी हो सकता है कि नेपोटिज्म के ह्यूमन एरर्स बहुत ज़्यादा पॉसिबल है, ह्यूमन एरर्स एंड मल्टीपल डेटा लीक हो सकता है ईजिली, और फ्रॉड बहुत ईजिली इसके साथ किया जा सकता है। Fraud cannot be detected, like we can say. So multiple problems we are facing due to this traditional attestation and verification and storage system of the degrees of the in Pakistan. So अब मैं इसका सोल्यूशन ये है कि सोल्यूशंस जो मैंने तैयार किया हुआ है वो है टू सिंपल थिंग्स: स्मार्ट कॉन्ट्रैक्ट which will work with the blockchain, and IPFS which will work for the storage of data of the documents. So these two main technologies will is the solution to the this traditional system which is the problem what we can say. तो अब मैं यहाँ पे आपको ओवरव्यू कराऊंगा कि हमारा जो प्रोजेक्ट है वो कैसे काम करता है और हमने इसको कितना डिप्लॉय किया है और कितना प्रोसेस में है। तो यहाँ पे हम आते हैं, ये हमारा प्रोजेक्ट है EduVault Web 3 के नाम से। हमारे पास इसका ये बैकएंड है। सो मैंने JWT का इस्तेमाल करके मैंने इसको ऑथेंटिकेशन पर्पस के लिए यूज़ किया है। वाइल जो हमने प्रोजेक्ट किया है वो है हमारे पास रिएक्ट में। सो वी यूज़ द रिएक्ट फॉर द फ्रंट एंड, वाइल नोट JS एंड टेलविंड फॉर द बैक एंड पर्पस, टेलविंड इज फॉर द CSS पर्पस, एंड दिस इज ऑल. सो नाउ let me run this code. Let me run this course. So here is to npm I'm sorry for the sorry, it's already run. So let me first yeah, so now let me start again. Npm start div. Now let me it must be, I'm sorry for the inconvenience. So it must be npm run start start div, because it I have running it with the white, so that's why this command is useful for working. So now let me run this. So here is, we have a website, the front end page, we can say landing page. Here it is. So now to first of all, the student will come on this page and register here. So he will provide like email. It can be anything like abc123@gmail.com, and password it can be anything 123 abc123 like this, and password it was ABC123 and this 3 times. There are multiple roles, like because these 4 are the main stakeholders of our project: the student, which is the main body; HEC, which is the owner of this all the system and to control the system; university, which will issue the credentials like degree to the students; and employer or verifier, we can say, which will to verify the student degree and to hire for the hiring purpose. So in a company or in other universities, as the degree is to be checked, so this portal will work for the authenticity purpose. So let me first play the role as a university. So let's sign up here, and it will route me to this university portal. The university portal is open. Save this password, and here I have a university portal from where the employer or the hiring person of the HSC in the university will control this portal, from where he will upload the documents to IPFS and then encrypt through the process on this through this platform on the blockchain. So here it is. Now let me submit and store a file on the blockchain, and not on a blockchain but on the IPFS. So I'm just dummy data that we can say that I will say that Sajid Khan, and here is a public address. I will say that it's a only dummy purpose, X763, like this type of data, and degree it is like BSIT. Date of issues like 02, 04 and 2024. Let me choose the file. So I have like this is the file, means the dummy degree. So just open and upload to IPFS. Now this will return me a CID hash function, hash CID. This is my hash CID that I use the IPFS. I use the IPFS platform to store these credentials in a JSON format on the IPFS. As you saw that this button returns me a CID which is provided by the IPFS platform. Let me copy this CID and I have to view this file. That is it true? Is it okay? So let me view the file. So enter the CID and let me paste it. So I'm going to check whether my credentials is all right. So yeah, so here is Sajid Khan and public key is mentioning also degree details and issue date, and here is the certificate. It is, I already said that it's academic data. So this CID I return from the IPS. Now other processes are in a process. So as I said that now this CID, I have to store it on the blockchain. As we know that blockchain is authentic, verified, and we can say having no third party and immutable, and it provides the integrity to the data that is stored on the blockchain. So we have to come on to this remix and ID, where I have already created a blockchain smart contract. So we have to deploy it first using all the proper configurations. So let me deploy it. Yeah, it's successfully deployed, as we can see here. And there are some functions, as it's a whitelist. So first of all, the HEC will have a whitelist, which function is to make a list of all those universities which are authentic by the HEC and verified by the HEC. So this button and this smart contract will provide a facility to HEC. The university applied for the HEC that I'm a university and I want to register in HEC. So that university will provide a university address to the HEC. HEC will simply add it. So let me just take address of address, any dummy address from Google. So let me get any dummy address of MetaMask. Yeah, so there is no. Oh, okay. Let me ask from ChatGPT. Give me dummy public key. So I get a dummy public key, and I have to use it for the testing purpose. So yeah, so just paste that public key, and name is like I have to say that this address relates to Quaid-e-Azam University. Also, Quaid-e-Azam University is already authentic university for in the HEC, but it's just testing. So Islamabad ISB. Okay, and here is, let's suppose, contact number 05123 and like this, some dummy data. Now this button will basically work for to store the to add the data into the whitelist, and here it's successfully transact. Every transaction will cost some gas fee. Now this button will work, this function will work to remove the university if HEC will not authenticate anymore. And here is a so what I said, that encrypted CID. So in my project, as you see that this is the this is basically the CID. So I just copy it, and I have to store it in here. Oh, not here, sorry, in the next button. It is CID, so it's here. And the public key, like just say this public key, it's just testing purpose, Control V, and I have just transact it. So it's so we have this setup in a process, so we are working with it. But for the idea that CID will first encrypt with the public key of student for the confidentiality purpose, and then it will be encrypt with the university private key for the authenticity and authenticity purpose. So this is what we have. So now there is another button, that is Get University. So means anyone who want to check the university that it's verified or not, so he will just use that public key, like public key what we have here. Yes, so just let me copy it, Control C, and paste it here, Control V. So yes, so let me call it. Yeah, it works. So as we just stored that Quaid-e-Azam University Islamabad, and the calling number like 051 and contact number, so it's work. And if we want to check that is it verified, is it true, is it verified, is it authentic, so let me paste the address, and in the same way just call this. So yeah, bool is equal to true, it's successfully called, and it's true, authentic, as we added this address into the whitelist. So this how it works. So just wait, I'm so sorry, where is my no, here it is. So as we are here in the university portal, so we just use this platform. Now here is, so as I said that encryption will be done, CID will be encrypted, double encryption, first with the student public key and then with the university private key. and it will first go to it will first call the smart contract to check the public key of university in the whitelist. If it matches there and it found there and means that public address is there, then the transaction will be successfully done. Otherwise it will get rejected and the degree will not store on the blockchain. So this is how we can say our system. So this will provide authenticity and the integrity of the data. How you can say how you will say how. So here it is basically just a university portal. Now we will move to a verifier portal. So just register and it's just for dummy data, gmail.com and password like 345. Select role. Here I am selecting role as employer as a verifier. So sign up successful. Yeah. Okay, save. Yeah, so here it is verify credentials. So you can see here is a search public key. This will provide the public key of any university. Why this is here? Just to decrypt the CID, which will be fetched. First of all, this platform, the student data will be fetched by the wallet address of the student. Verifier will put wallet address to this file, this input bar, and with the university public key means here he will the employer or the verifier will give the university public key from here search public key. So this will how this will work. Like wallet address will fetch the data of the student, means that doubly encrypted CID which is stored on the blockchain, that will be fetched here, and it will first decrypt with the university public key as we just input here. This search status will show whether it's verified. If first of all, if it fetch from there, so yes, one thing is that the CID is authentic. The second thing, that university public key, if it decrypt it that CID successfully, so this will provide as it is, as we know that digital signature provides that authenticity. So here the green mark will show the verified. Also now the verifier will face another phase, that is basically we can see that we said that it is it is first encrypt. The CID is first encrypt with the student public key, so only student can check the CID. So this platform will send message to the student and request for the decryption of CID through his her private private key. So now the student will get sent back, and in here the verifier will provide student public address, decrypted CID that is provided by the student, and encrypted CID that is original, means fetched from the blockchain, and he will check here. So this will provide the fraud, because student can share any CID with the verifier. So here is a file where we can verifier can view the. So in this way we achieve the authenticity of the degree, the authenticity plus the integrity of the data, and even confidentiality of the data. So these three main points which is provided by the HEC, this traditional system, and it's not even too much strong. But what are the main features? It's time efficient, cost efficient, the main 2 points what we can say, and it's basically very helpful in fraud. Means no one can apply on the fake degrees to the companies. First thing. Second thing, that it will reduce time, as we said earlier, and cost with this, as we know that it's Pakistan. So these are the main features of our project. Thank you very much for listening our project for this video.